I'm Ben Schreiber, and welcome to Music Algo. My goal here is to make algorithms plain, simple, and memorable with mnemonic devices. So, in this video, I will be showing you how to execute binary search without the use of the computer so you can develop a feel or a foundation for how binary search works. Next, I'll do an analysis on binary search, and the third video is a musical algorithm, music algo as I call it, that'll show you how to execute binary search and gives you some facts and analysis. So here's the intuition behind binary search. So here's our agenda. First, we're going to discuss the general binary search procedure. If you don't understand this right away, no need to worry, because we're going to go through a couple of examples after we discuss the procedure. Now, for clarification on some topics and vocabulary that might seem a little foreign to you, please check out the prerequisites section of my site, musicalgo.com. So, binary search is an algorithm that searches for a number that we call a key. A number or a value doesn't have to be a list of numbers in a sorted list, and the parameters low and high can be used to specify an area of the list which you want to search for the key. Now, to avoid confusion, low and high are positions or indices. They are not values, so remember that. Low and high are positions. So if you want to search for the entire list, you can set your low to 0. So here we can see the low is at position 0. And you can set your high to the length of the list -1. So we can see that high is at position 3, which is the length of the list 4 minus 1. So before we get too deep into the procedure, you should know that binary search gets its name because it successively cuts the list in half till it finds the key's place. Now, this is extremely useful because we don't have to look at every single value in the list before we find the key. Here we do our most log base 2n lookups for a list of size n. This is also why sorting is so important, because if the list isn't sorted, we can't do this. We can't save all this time. So if you didn't understand that, I highly suggest you check out my analysis video on binary search. Anyway, moving on, we first see while low is less than or equal to high, we do the following indented stuff. First, we find the midpoint between the low and high indices. For the sake of simplicity, we're going to say that the mid equals the quantity of low plus high divided by 2 and round down to the nearest whole number. So here's why we round down. Say low were 3 and high were 6. We take the sum of low and high, that's going to be 9, and we divide that number by 2, which is going to give us 4.5. There is no such position 4.5, so we can't possibly set our mid to 4.5. So typically when we divide integers in programming, we round down to the nearest number, so that's what we're going to do here. So if the value at the midpoint is greater than the key, we set high equal to mid minus 1 and we keep the low position. If the value at the middle position is less than the key, we set low to mid plus 1 and we just let the high be. If neither of these if conditions have been met, we found the key at the mid index. So once this indented stuff is finished, we check whether low is still less than or equal to, or LEQ for short, to high. If it is, we loop again. If it is not, the key does not exist in this range between the low and high that were input to the binary search function. Let's take a look at an example. Here our list is 10, 15, 17, 19, 20, 21, 22, and we search for our key, which is 9, in between the low index, which is 0, and the high index, which is 6. 9 is not in this list. This is intentional. I want to show you what happens when binary search does not find the key. So entering iteration 0, our low index is 0, high index is 6, and our mid index is going to be 0 plus 6 divided by 2, which equals 3. So the low I'll indicate with an L. That's an L. The high with a little h. And the mid with an M. So we see whether the value at the middle position is greater than the key. It is, so we set high equal to mid minus 1, and we keep the low position. So we figure that our value can only exist within this range because the list is sorted and 9 cannot possibly exist after 19. So entering iteration 1, our low is going to be 0. Our high will be 2. And our mid will be 0 plus 2 divided by 2, which is 1. And writing that down, we have our low at position 0, our mid at position 1, and our high at position 2. So we see if the value at the mid position is greater than the key. It is, so we set high equal to mid minus 1. So since our key is less than 15, it cannot possibly exist to the right of it, so we figure that it can only exist to the left, which is basically one number. So now our low is the same, 0. Our high is also 0 because the mid was 1 in the previous iteration and we set the high back 1 left to the mid. So everything is at position 0. 0 plus 0 divided by 2 is 0. So the low, the high, and the mid are all at position 0. And because I don't have enough space, I'll just say star is at 0. That's low, high, and mid. So is the value at the middle position greater than the key? It is. So I forgot to write down that everything is at 0. So is the value at the middle position greater than the key? It is, so we set high equal to mid minus 1. So now our low remains the same. High is equal to negative 1. And at this point, we break from the loop. That condition where the low is less than or equal to high has been broken because now the high is less than the low. And with that information, we can say definitively that 9 does not exist in this list. So let's take a look at another example. Here our list is 10, 15, 17, 19, 20, 21. We are looking for the key of 19 in between the low position, which is at position 0, and the high position, which is at position 5. So we're searching for 19 through the entire list as our range. So entering iteration 0, our low position is at 0, our high position is at 5, and our middle position is at 0 plus 5 divided by 2. And since we round down, that answer is going to be 2. So our middle position is at position 2. So the low is at position 0, the mid is at position 2, and the high is at position 5. That says high. Okay. So we see whether the value at the middle position, 17, is greater than the key, 19. It is not. So then we see if the value at the middle position is less than the key. It is. So in this case, we set low to mid plus 1, and we just let the high be. So we say since our key is greater than the value at the mid position, it can only exist to the right of it, within this range. So now our low is at position 3, our high is at position 5, and our mid is going to be at position 3 plus 5 divided by 2, which is 4. So high at 5, mid at position 4, and the low at position 3. So is the value at the middle position greater than the key? 20 is greater than 19, so we set high equal to mid minus 1. Since the key is less than the value at the mid position, it can only exist to the left of the middle position and to the right of the low. So there's really only one value where it can exist. So now our low is still at position 3. Our high now is at position 3 because the mid was at position 4 and we moved the high down by 1. And the mid will also be at position 3. So like I did in the last example, I will denote that with a star indicating that the low, the high, and the mid are at position 3. So, is the value at the mid position greater than the key? No. Else, if the value at the middle position is less than the key, we set the low to mid plus 1. That is not the case though. So, since neither of those if conditions have been met, the key exists at the mid index, which is the case. We see 19 exists at position 3. So, we return to the caller of this function that 19 exists at position 3. So, I hope you found this video instructive. Now you may be ready for the binary search analysis, which will tell you really how useful binary search is in the real world. And after that, you'll be ready for the binary search song and code so you can have it forever. Now, if you have any feedback for me on this video, I'd love to hear it. And if you really like this video, I'd appreciate it if you share it with your friends. And I also thank you for watching.